Lesson 3 of Chapter 2 is interpreting graphs. So we're going to look at different kinds of graphs and understand what they mean. So we have this example here. The graphs show the speed of 3 snowboarders during a race. Tell which graph corresponds to each situation. So we have graph 1, graph 2, and graph 3. It measures speed on the y-axis and then time on the x-axis. So if the speed is all the way on the bottom here, that means it would be stopping. And then up here would be very, very fast. Let's look at these situations and see if we can figure them out. Jordan gets off to a good start and continues through the course, picking up speed. So no matter what, they're starting at a stop, but he gets off to a good start. Well, we see good starts at all 3 of these, so they could be anything so far. Then continues through the course, picking up speed. So it looks like he never slows down, right? So here, he never slows down. It looks pretty good. This one, we have a slowdown. That means this one can't be it. This one, we could say we could be tempted to do this, but here he's not picking up speed. You see that? His speed is staying the same near the end. So that means it would have to be this graph 1 over here. So we're going to say graph 1. Now we have this one. Ethan gets off to a good start and picks up speed. Toward the end of the race, he nearly falls and his speed stops increasing. He rights himself and finishes the race, reaching his greatest speed. So we have this one, which he clearly he never stops. His speed stops increasing. So we can probably look at this one that we were looking at before. Gets off to a good start, increasing his speed. Here he almost falls. His speed stays the same, but he finishes with the fastest speed. And this really fits that graph well. So we'll say graph 3 is this situation. Let's see if this goes off to graph 2. Xavier gets off to a good start but falls around the middle of the race. He gets up and he finishes the race, gaining speed through the finish line. So we see that getting off to a good start. Ooh, he fell. So his speed went down to 0. So after he got up, he went faster and got down the hill. So this would be graph 2. So here we're going to distinguish between continuous and discrete graphs. Continuous means that it's a straight line. There's nothing interrupting the flow of the graph. Discrete graphs means that there's different points on the line. So this one's a pretty clear one here. See this continuous graph? It's going all the way through. There's nothing breaking up the points on the line. So we would say this one would be continuous. And we see we have breaks in the line here. So that would make this a discrete graph. Everything that has breaks in the line would be discrete. Simple enough. Moving on to these ones. Here we need to create a graph for the situation and tell whether the graph is continuous or discrete. So we have the table shows the altitude of an airplane over time. So when you take off, you're at 0. You go higher and higher and higher into your flight. But then near the end, obviously, you're going to be descending and you go back down to 0. So we actually need to create the numbers on the graphs. Like, how should we label our graph? A good idea is to look at the highest one, 30,000. And the lowest one is 0. It's usually a good idea to start at 0 unless you have way too much information to show. So we'll have 0 here, but then we need to figure out what we can do. And sometimes this is a little bit of a common sense decision. I could say 5,000, 10,000, 15, 20, 25, 30. That fits it pretty well without going over and then without being too crunched. So we'll do that. I'll do 10,000 right here. So 5,000 to 10,000, and then skip 2 again, that'd be 20,000. Then skip 2 again, this will be 30,000. That's probably where I can stop. So this would be 40 and that would be 50, but I don't need those. And then we have 90 total minutes, and we only have, we can't count by ones because we won't get all the way to 90. We can count by tens maybe. So we'd say 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. So that's all the farther we have to go. So after 10 minutes, the plane is at 10,000 feet. So here's where we would do that. 10 minutes, 10,000 feet. Here we have 20 minutes at 20,000 feet. So 20 and 20,000. Here we have 30 and 30,000 feet. So we're seeing a trend here. Here's where the trend stops. 60. So it skips 40 to 60 probably because the plane just stays at that level. So we'll skip the 60. We'll put 30,000 here too. And then 70 would be 20,000. Here we're coming down. 80 would be 10,000. and then 90 we're back at 0. So maybe we'll mark that with a 0 here, and then 0 here as well. So this would be labeling our graph here. We're creating this graph. The question here is also, is it continuous or is it discrete? For example, for the plane, when we're between 0 and 10 minutes, are we on the ground again, or are we nowhere? Certainly not. Or between 10 and 20, are we somewhere on the ground here? No, you would think that we'd be continually to rise. We're always going to be in the air. So this would actually be a continuous graph, because the plane between these points is still rising, or in this case, staying the same height, or in this case, descending down to the ground. So it would be a continuous, because no matter what, the plane is always in the air.